Hello there and welcome to Lower 6th Further Maths A-Level January Mock Exam Revision Sheet 2, and here we're working on question 3. We have two complex numbers z and w, and we have some information about them. Express the following in the form r cos theta plus I sin theta. Right, okay, so to start with we're going to be converting the z complex number, which is written in x plus yi form, into a modulus argument number. So to start with, the modulus of a complex number that we're representing with an r here is the distance from the centre of an argand diagram to the coordinate on the argand diagram that's represented by the complex number. So this number here is going to be minus 9 plus 3 root 3i. And the distance of this line, the modulus of this line, is going to be the distance from the 0 to the coordinate. Now if we think about this as a triangle with positive lengths, this is going to have a positive length of 9 and a positive length of 3 root 3. So using Pythagoras' theorem here, it's going to be the square root of 9 squared plus 3 root 3 all squared. And either type that into your calculator or work it out. 81 plus 27 will give you 108, which is the same as 6 root 3. Okay, so that's the modulus. The argument is going to be the angle between the real axis, so this line here, and our complex number round to here. So this theta angle here is our argument. But what I'm going to do first is calculate the alpha angle and use tan to help me work that out. And what I'll then do is just do a pi minus the alpha angle to get me my theta angle. So to work out alpha, it's tan because we've got opposite and adjacent sides, and it's going to be adjacent, so opposite over adjacent, so 3 root 3. 3 root 3 over adjacent 9, which is going to simplify to tan minus 1 of 1 over root 3, which will simplify to pi by 6. So therefore the argument of z is going to be pi minus pi by 6, which is going to be 5 pi by 6. So this angle here is 5 pi by 6. And just to finish off the question, z we'll write as a complex number in terms of modulus argument. So it's going to be r first, so that's 6 root 3, bracket cos theta, so that's 5 pi by 6, plus I sin 5 pi by 6. Okay, we can also check this on a calculator. If you go to the menu button, which is in the top row of your calculator, select option 2 for complex numbers, type in your complex number. Now you need to use the purple I button, the eng button here. You don't need to press any of the shift or alpha buttons at the top. Just press eng and that will get you your I up. Press enter, and then you need to go to option, scroll one option block down, and you'll get answer to r theta form. So then you press enter on that, and you press enter again to select your answer, and it's going to be 6 root 3. So that's 6 root 3 here is representing the modulus of our complex number, and 5 pi by 6 that's here is representing our argument of our complex number that's there. Okay, so it's useful to know the calculator does that for you. Part B, which we're now moving on to, which is W. Now W is a lot easier because we've already got the modulus and we've already got the argument, so all we need to do there is just write our answer in the correct form. 3 bracket cos 7 pi by 12 plus I sin 7 pi by 12, and that's all you need for that question. That's your final answer. Part C is ZW. So what I'm going to be doing here is using the rules for modulus as an argument, where if you want to work out the modulus of a complex number combined with another complex number with a multiplication, you multiply the two moduluses separately. And if you want to find the argument once two complex numbers have been multiplied together, then all you need to do is add together the two arguments. Okay, so that's a general rule here. Your teacher will have shown you this in lesson, and you can just use this in your exam. So to find the modulus of ZW, we need to do the mod of Z, which is 6 root 3. So working out mod of ZW first. That's 6 root 3 times by the mod of W, which was root 3. So root 3 times root 3 is 3, times by the 6, we get an 18 there. And for arg of ZW, it's going to be add the two angles together. So 5 pi by 6, add together with 7 pi by 12. And this is going to equal, it's going to be 10 over 12 pi, so that would be 17 pi over 12. However, we always want our argument, to be in between minus pi to pi. So if it's 17 pi by 12, then taking that away from a full circle, 2 pi minus 17 over 12 pi is going to equal, that's going to be 24 minus 17, which will give me 7 minus 7 pi. That's 7 pi over 12 minus, like that. Okay, so instead of it being on the bottom half, this doesn't exactly equal it, but this 17 pi by 12 here is going to be the same angle as minus 7 pi by 12 here. So our final answer for this question here is going to be, so we just write it in complex form. So ZW equals, so the modulus of our complex number, which we worked out here, was 18, bracket cos of minus 7 pi by 12, add I sine minus 7 pi by 12. To explain this a little bit more, let me just draw a diagram to help you visualize this. If we want 17 pi by 12, well, we need to go around 17 lots of the 12 pi's and then round another 5. So we're roughly down to here. So this round from here is pi, and this round from here to here is that extra 5 pi by 12. But when we're writing out our argument, we always go from this line and either on the top round this way or on the bottom round this way. So in actual fact, what we want is this angle round here, this theta angle round from here to here. So given that it's on the bottom, it needs a negative, and if it's 12 pi by 12 all the way around, it needs to be 7 pi by 12 for this part here. But given that it's also on the bottom, it needs a negative in front of it as well. So the argument for this complex number down here is minus 7 pi by 12. Okay. Part D is now Z divided by W. So let's think about what rules we need for Z divided by W for the modulus. Well, for when it's divided by, you divide by your moduluses in exactly the same way. And if you're finding the argument once two complex numbers have been divided by each other, you have to subtract your complex numbers from each other, like that. Okay, so for mod of Z over W, we can now just use these rules your teacher has proven to you in lesson. So it's going to be 6 root 3 over root 3, which would just be 6, and arg of Z over W is going to be, so the Z1 was 5 pi by 6, and the other one was 7 pi by 12, so we're going to subtract one from the other. So that's going to be 10 pi by 12 for this 5 pi by 6, take away 7 pi by 12, that will leave me with 3 pi by 12, which is the same as pi by 4. Okay, so the complex number z over w is going to equal the modulus part first, 6 times by cos of pi by 4, add I sine pi by 4. Okay, so there we are, that's this question complete. So here with these rules, the rules where you multiply your moduluses and add your arguments for z times w, and the one where you divide your moduluses and subtract your arguments for z over w, are common rules that you need to learn for the January exam and for your summer exams as well. You can just use them, you don't necessarily have to state them like I have, but you do have to remember them, and you can use them straight in an exam. Okay, so make sure you remember these. 7 marks for this question.